This video I'm going to go through the adjustment of the brake motor, which comes on all the Laporte skeet and trap machines. The brake motor is made up of 3 different parts. One is the cast iron cooling fin, 2 is the center disc with the brake material epoxied to it, and the 3rd part is the coil or the magnet. There's 3 springs between the coil or magnet and the center disc with the brake material glued to it. When the motor's not running, these 3 springs keep the disc pushed up against the bottom of the cast iron fin, which stops the motors instantly. What I'm going to do is we're going to go through the adjustment of this now. Let me get a 3mm Allen wrench. This is the screw we do our adjusting with. And I'm going to use another Allen wrench right here to hold that, since I'm holding the camera with one hand. What I'm going to do is tighten this and bring it down until that gap right there is gone. This cast iron fin will come down and come in contact with that brake material. See if I can get right here. You can probably see it coming down. Almost there. Right there. The first 2 pieces are together. Notice that I can move this back and forth just a couple of thousandths. These 2 pieces are locked together now, this and this. I still have my other gap right here, which we're going to continue to tighten this screw and bring this and this. Both these pieces are going to come down and close that gap up right there. And just as soon as all 3 of them come together, when these 2 come down and touch that, I won't be able to move this back and forth no more. Let's see if I can show that on camera here. Alright. Still move it. Still move it. Still move it. Right there. I just felt them come together. The gap's closed up. All 3 of these are now fully tied together. So just as soon as all 3 of those came together, I stopped. They're locked up. I'm going to take a 3mm Allen wrench here. The adjustment is to back this up 1/2 of a turn. We'll look where Allen wrench is, and I'm going to come backwards 1/2 a turn, loosen it 1/2 a turn right there. I'll probably have to use a ball peen hammer to make sure. See, I'm taking it right there just a little bit to make sure that this, remember this is a pretty tight fit on the shaft of the motor, so I needed it to come slide backwards at 1/2 a turn. Now when I back that up, I've got a little bit of a gap. See the movement? These 2 aren't together no more. I've got a tiny little gap right here, and that gap is proper. 1/2 of a turn. It's I forget how many thousandths it is, but it's a 1/2 a turn with a Allen wrench. Now this motor should run properly. Let's just see if we can plug him up here. And I'm going to reach over. Sounds just fine. Running. This micro switch. Stop. You can hear the motor running smoothly. No dragging. You can actually hear the brake working. It turns off, you hear it pop out. Stops the motor, and you can actually hear it pull in when the motor starts. What I'm going to do now is show you an out of adjustment situation. I'm going to back that up, this adjustment screw, an additional 1/2 a turn. We come out a 1/2 a turn. Now I'm going to come an additional 1/2 a turn. Again, since I'm backing backing it up, I'll have to make sure this comes back by pecking on it a little bit. Once again, I'm going to turn it on. Let's try it. And now you can hear it's dragging. What we've done when I backed that up another half a turn, this gap right here got so large. This disc is so far away from that, just another half a turn, that disc can't, the coil can't pull that disc down away from that, and it's dragging. If you'll watch, it never pulls down. But it's dragging. You can actually hear it. What's happening there? Someone might think it's a proper adjustment. Go ahead and start using put it back on the machine and use it. And what might happen, certainly what's going to happen, is you'll get a lot of heat built up from the friction, from the dragging. The other thing that'll probably happen is the motor's using quite a bit of its power just to slip this. You know, I can turn that, but it's quite hard. And since the motor is using most of its power just to slip that clutch, per se, as soon as the cocking studs on the machine here probably come around and come together, it'll probably just stop and lock up, because it won't have enough power to slip the clutch and to recock the machine, you know, overcome the tension on the spring. Okay, let's take our Allen wrench and put it back into proper adjustment. We'll tighten it back up 1/2 a turn. This should be back in proper adjustment. I don't have to peck on it because the screw physically pulled this down. I'm going to try it now and see if we're back where we need to be. We should be able to hear it. You can hear the brake pull down, running normally, and you can hear the brake pop up. So now I'm going to take it the other direction. I'm going to take it in. Let's try to run it right there. What I did is took it back in a half turn and turn it back off. Everything's still hooked up. I'm putting power on the motor and it's sitting there physically locked up. You can't turn it because I took it back in. All three pieces are pulled together. Let's say someone only came out about 1/4 of a turn. Since we're backing it up, I'll bring this back. Let's try it. Now you hear it starting to drag a little bit. See, I can move it back and forth. I'm going to bring it down till they all come together, which is right there. Can't move it back and forth. All three pieces are together. I'm going to back it back up our 1/2 a turn for adjustment. This would be your like we talked originally. All three pieces are pulled together now. Back it up our 1/2 of a turn. Make sure this does come back 1/2 turn. There it is. Hopefully I've covered that pretty good. You can, if you get into this, want to do it yourself, certainly feel free to give me a call. Give us a call here at Laporte.